Hello and welcome to the AIoT Hub, your source for all things IoT. Hope everyone's enjoying the great weather we're having at the moment. I've just come back from kayaking in Montenegro and Albania, where we had lots of nice sunshine and warm waves. How is it with you, Rajni? Might need to unmute yourself.
I had to unmute myself. Yes, rookie mistake. Well, I'm in London. As I hear, I feel London has much worse weather than up north in England. So quite a role reversal. But we had a heat wave last week. I don't know what it was like. Probably you weren't around. It was terrible heat wave. So actually, wet weather is much more welcome.
Yeah. Okay.
Yeah.
It feeds the garden, I hear. Yeah.
It feeds the garden. Yeah, totally. Also slugs.
So tonight we have Dr. Kurosh Aslansefat. Apologies if I haven't pronounced that correctly. We've discovered in the chat beforehand that we live in the same area in Leeds, the best place for all things, and where we have glorious sunshine at the moment.
Yeah.
And you work in where most of my family come from, in the glorious city of Hull.
Exactly. Yeah, at the University of Hull.
Yeah. So this is the rescheduled talk, which your professor was going to do, but then he was sick and now he's had to cancel. So thank you so much for stepping in at the last second and joining us here.
Happy to be in this community.
Do you have any IoT news that you want to share with people, Rajni?
Yes. Hello, everyone. I just was wanting to share this Edge AI event in London next week, and people who are interested. I think the full conference pass is in the region of £250, give or take, but the list of speakers and the topics, I think, are very, very current and relevant. So those who are interested, I would highly advise give it a look. And if you can. And in fact, if somebody's going, shout out for a coffee. I might be around as well.
Always good to network. So next month we have IoT data drift happens. AI is to the rescue, continuing our theme of AIing all the things and solving problems using AI. So if you're like me, you're finding your industry is being turned upside down by AI at the moment. We need to I feel I need to sort of keep up to date as much as possible. So we have Avinash Suwali joining us from Pune in India, and he's going to talk to us about that. So enough rambling from me. Over to you, Kurosh.
Thank you. If I may, I'm going to share my screen and provide the presentation for today.
Okay, as always, if there are any questions, please put them in the chat. We can ask them live. Tell us where you're joining from. Also, we'll put that in the chat as well. So please put questions in the chat.
Can you just tell me that my presentation is visible?
Yeah, it's all good.
Okay, good. So first of all, hello everyone. My name is Kurosh Aslansefat. I'm an assistant professor at University of Hull in computer science. I do research on AI safety and explainability. And I am a deputy lead for Center of Responsible AI at University of Hull, and I'm co-lead of another center called Dependable Intelligence System. So our university is part of a national Edge AI hub that I'm going to talk about it later in some slides. And today's talk is about the next frontier in responsible AI, explainability and fairness on the edge. So the outline of the presentation that I have today is going to be in two parts. One is responsible research in responsible AI and Edge AI actually. So what we do as as part of real world applications, I'm going to share two of the recent projects that we have. And then I'm going to talk about responsible AI and specifically the let's say, Edge AI version of it. What are the challenges and what are the state of the art, and how we could kind of say answer those challenges. So before starting, I would like to talk about this research center that we have. So we have Responsible AI Research Center. We are kind of, let's say, more than 20 people doing research in various kind of, let's say, domains with regards to responsible AI. We are targeting three main pillars of responsible AI. The first one is trustworthy, when we are talking about solutions that make AI safer and how we could kind of, let's say, make them more robust. The other one is explainable. So we want to kind of say make the AI more understandable by designing various kind of approaches, such as using certain neurosymbolic AI, or kind of, let's say, developing a new method for explainability that I'm going to also talk about them later. And the third one is the equitable AI, that we want to make AI fair. And we are again designing and developing new kind of, let's say, approaches for individual and group fairness. We want to tackle different challenges that we have with regards to kind of, let's say, detecting bias in AI algorithms and how we could kind of mitigate such biases. So let me jump into real world applications. So one of the first application that we had is the use of a smart AI speaker for adult social care with a company in Hull called Connexing. So we targeted one of the kind of important problems, that is documentation burden in adult social care. This project was funded by Innovate UK and recently concluded. So we know in this specific domain, the burden or the barrier of kind of, let's say, documentation, kind of in a UK-wide study, it has been shown that 37.8% of social workers said documentation pressures had led them to consider leaving the profession. Also, two-thirds reported working in settings with unsafe staff to service user ratios associated with significantly lower mental well-being and higher work-related burnout scores. So these are the kind of challenges that lead us to design something to help this kind of, say, specific domain. So one of the solutions that we tried to have for this specific problem was to use smart speakers. So for each kind of, let's say, houses, or for each kind of, let's say, adult, we were designing kind of, say, a specific uh, smart speaker. We wanted this speaker to have a kind of functionality. For example, we could have voice control for everything, and a screen to show, recognize a speech as a text, and a kind of, let's say, sound feedback as kind of confirmation. And with regards to kind of, let's say, smartness or the intelligent part of it, we needed to have speech to text recognition. We wanted to understand the queries and return the relevant information. And we wanted these kind of, let's say, these ones to be computationally kind of, let's say, intensive, to be run on that kind of, let's say, specific edge devices as much as possible. And a lot of challenges happen during kind of, let's say, implementation. So I put a kind of, let's say, real picture that we had from this prototype that we were designing with Connexing. So we had a kind of, let's say, a box with a Raspberry Pi, and we had a speaker, and kind of, let's say, we were kind of connecting a kind of, let's say, specific points to this. And we wanted to use this one as a solution. So we were trying to see how we could make this more responsible, how we could make it trustworthy. So let me first go through the kind of the way this smart speaker was working. So we could say that we have the first phrase, the first part, that we say activate. So that is waking the device up, and then you could choose the kind of, let's say, the record section. So you could say mobility, personal hygiene, medication, and etc. And then you could record transcript, and you could talk about, for example, a specific problem. or you could ask about a specific problem, and then at the end you could sign it off or retrieve the information. So we were designing a couple of kind of, let's say, commands. So for example, how we could have a specific resident ID, how we could have a restart, undo, disconnect, and other kind of, let's say, commands within this smart speaker. So we all know that they kind of say we have the rise of large language models. So we were thinking that, okay, if we use this generative AI solutions, how it can be possible to do it for a kind of say a restricted device. For example, we have a computation restriction on Raspberry Pi, and how we could make it trustworthy. So that was a very kind of, let's say, real challenge. We had various tasks as well. So we were, for example, designing this system in a way that you could ask a specific session to be what we call it booked for this patient. So you could say that, okay, for this resident 0001, we need to have a specific section as session at this time. And the smart speaker should book the calendar with the right amount of kind of, let's say, time and then specific kind of, let's say, command that you set. So people that are trying these things, they know that sometimes these agents are making mistakes. And if we, for example, if for a specific type of commands like medication, if you make a mistake, it's really going to be kind of, let's say, destroying the whole project. So the trustworthiness is very important. So when one of the things that we were trying to do as part of or in parallel with this project was to design an AI assurance framework and with kind of related to this application. So we were trying to see what does the AI assurance means for us. We were trying to have different categories, for example, responsibility, performance part, operation, and compliance. And then we were trying to see how each of them has kind of a specific meaning for this specific application. So imagine that we have, for example, safety and security one. So we could have key points like prompt injection and data provisioning. We could have human in the loop verification. We could have access and exposure controls. And what would be the risk and what would be the impact? So again, we have developed each kind of say examples for each of them, and we were trying to see if we could have a kind of comprehensive framework around this. So if you want to read more about it, just search this a specific paper that we put online. The second thing that we were thinking about was that how, when it comes to the use of, for example, any generative AI solutions for example, on a smart speaker, uh, a lot of people are trying to kind of, let's say, test it or verify the correctness of the behavior of that device. But we were thinking a bit in a higher level. For example, one of the approaches that was kind of was proposed by also a security institute in the UK is the use of kind of, let's say, systematic diagrams like safety cases. So how it works is that you design or you define a specific goal. For example, the goal here is the deploying the smart speaker that does not pose unacceptable risk. And then you decompose that kind of, let's say, the existing risk to several subcategories. For example, you may have retrieval or the kind of, let's say, RAG, retrieval augmented generation. So you have a specific risk associated with that part. You may have a specific kind of, let's say, risk associated with speech recognition or a speech to text part. You have the kind of risk related to robustness. You have the risk related to explainability and many other kind of risks. And again, you for each of them, you can break it down to various kind of, let's say, sub levels. And then for each of them, you could try to see, for example, what is the kind of say performance metrics or what is the risk. So you can see that, for example, for C11, we are breaking down that one to, for example, the category ID accuracy, residence ID accuracy, and we could see the kind of say transcription accuracy and many other kind of aspects. So by defining a diagram like this, we were being able to make it more systematic way of kind of evaluating our application, our specific application. And one of the other things that we were doing, or at the moment we are also expanding, is the use of trustworthy small language models. So when we talk about, for example, edge devices, we know that we have a resource constraint. We don't have that huge kind of GPUs on the edge usually. So that is the problem, and we need kind of, let's say, language models that are small enough to be able to, for example, be executed on a Raspberry Pi or, for example, on a mobile phone and so on. So for that one, we were trying to have at 4 different phases to make sure that we are designing a trustworthy small language model known as SLM. So the first part was synthetic clinical data generation. So we were trying to use bigger model as a teacher. For example, you could say ChatGPT 4o is a bigger model and it is a teacher model. And you try to synthesize the conversation, for example, between doctor and patient. The other thing is that you have a knowledge base, you have clinical kind of guidelines, you have a kind of a different clinical databases. So you could make it a evidence-grounded RAG solution here, and you connect these two together. Having these two together, and then you are going to have teacher-student model, and then use that kind of as a combination to do the fine-tuning, to build your SLM. And then once the SLM kind of as a design, you could have multi-dimensional trustworthy evaluation from different kind of, let's say, automated metrics. You could have kind of, let's say, metric like Bears score, ROG, and so on. And then you could have additional scores like LLM as a judge. You could have an uncertainty evaluation, and you could have a kind of, let's say, explainability for generative solutions. The one that we were using in this project called Smile, that I'm going to talk about it later. So these 4 steps were helping us to design trustworthy SLM for these kind of applications. The second application that I'm going to talk about is called kind of, let's say, Trust LLM. We had a kind of, let's say, planning law company in Leeds, a relatively small company. They had 20 years of kind of, let's say, experience dealing with different cases for planning law. And one of the problems that they were mentioning that they have is to use a kind of, let's say, the AI for having a corporate memory. Imagine that you have a new kind of customer. It is having a specific problem, and you know that you solved it 5 years ago or 10 years ago, and you had similar kind of, let's say, cases. So you want to find that kind of, let's say, evidences or that kind of, let's say, documents, and you need to also gather different documents and evidences. And it is a kind of, let's say, documentation heavy kind of, let's say, industry. So for these kind of problems, we were kind of getting that for each case, it is getting up to 10 hours of skilled lawyer time per task for using kind of, say, for getting the kind of, let's say, information. And using LLMs at the end of this project, we're helping them to do it or to reduce it to 4 hours by, for example. And it is a lot if you consider the number of projects that they have, the number of people that working in this specific law firm, and how it could kind of, say, increase the productivity of that specific company. So for this specific company, we had a challenge, and the challenge was that the company, first of all, the owner of the company was not willing to kind of, say, use any cloud-based solution. So everything should have been kind of, let's say, done on a specific device, for example, on a PC, that could also be considered as an edge device. And the other thing that we had was that there was a very kind of, let's say, disagreement or kind of, let's say, trust issue, whether this AI is going to provide a good job. So one thing that we were very careful, and one thing that was challenging for us, was to design the system in a way that we are not destroying the trust level. And because trust for many industries similar to this is a barrier. So if you are on a startup and you want to make a solution for these kind of, let's say, domains, one of the barriers is just kind of, let's say, the trust level that people have in different kind of, let's say, categories. So we were thinking about the building a trust level. We were thinking about the kind of, let's say, how it can be fully local, no cloud kind of computation. And the other thing that we had was the restricted kind of, let's say, resources that we had in this project. So altogether, we were thinking that how we could make a trust LLM solution that is kind of, let's say, tailored or designed for this specific need. So it was a customized approach. So at the beginning, we built this solution as Trust LLM, and for planning law. Later, we improved the name when we now have the responsible LLM solution. We call it responsible LLM. But to simplify the way it works is that we have the input prompt. We have a layer, for example, for security prompt injection detection. And then we have a local model. So we have a lot of open source models like Llama, Falcon, Mistral, and so on. And one thing that we wanted to do on the left side, you see that we had various categories. For example, we had expert knowledge, 20 years of kind of, let's say, different cases. And the kind of, let's say, the knowledge that the lawyer himself has, and the planning law archives. And then we have the update on the government kind of, say, rules. For example, maybe there is some updates on the kind of, let's say, planning law rules that we have. So you need a solution that would check a specific websites or rules to get updated. So we were using this information to design a domain-specific knowledge graph for planning law to capture that kind of, let's say, knowledge that they have and use kind of, let's say, retrieval augmented generation or advanced retrieval augmented generation to kind of say feed it back to the large language model. And we were also designing a process for fine-tuning the large language model to understand some concepts in the low domain. But one thing that we were doing in this specific project was the other thing that we had in the right part. We call it trust layer. So in the trust layer, we have various kind of components from the explainability, from the hallucination detection, from the domain-specific guardrails that we had for this project. That the domain-specific guardrail was designed to understand what is the red lines for this specific case and for this specific domain. And if the LLM goes beyond those red lines, this guardrail should immediately kind of, let's say, filter those responses and notify us. So one thing that we were trying to do, we had this trust layer and we were building a dashboard for the user to see the kind of, say, what is the hallucination level? Whenever you have a response from this system, is it kind of, let's say, confident enough or not? So the user could easily see that is not the case, for example, for many of the chatbots that you interacted at nowadays. So you could kind of say in this system, exactly see, okay, what is the confidence of the model for this specific response that we get. And that was the idea that we had. So to just clarify a bit about these topics and about these issues. So when I was talking about the challenge of, for example, trust, you can see that a lot of examples are on the kind of say news outlet, and a lot of kind of say different versions you can see from DPD, from the BBC News, and other kind of say issues. You can see that a lot of things can go wrong, and this is one of the barriers that we have. So, for example, for the lawyer case or for many other cases that we do kind of knowledge transfer project, we see that kind of the trust is not there. For it is a barrier for them to accept the technology. And the other thing is the kind of shadow AI issue. We have a lot of kind of, let's say, major news about, for example, the shadow AI kind of say happening for different companies. One of them is the kind of say the Samsung one, that they were saying that the sensitive code was leaked. So these are, again, another important part, that kind of, let's say, push people to ask us to have a local model for them, very kind of, let's say, isolated without using cloud and so on. So having a trustworthy model that is running locally, customized for that specific businesses. And that was the kind of, let's say, one of the other kind of, say, areas that this industry had. And one thing that I wanted to mention is that, uh, for example, many of us in kind of say an AI domain may have used RAG for combining it with LLMs and getting, for example, putting a document there and asking, for example, using RAG to retrieve some information. But one of the important thing is that a lot of the functions that we have that can do kind of, let's say, this retrieval for us, they have the capability to highlight the parts that they were kind of, let's say, using to provide the answer. And I wanted to show you that, okay, if we have a document, it is a hypothetical document, it can kind of, let's say, highlight different parts that was selected and then feed it to LLM to provide me the response. And this one could increase the trust, because for the lawyer, for example, case, we could easily show the highlighted part of a big document, and the kind of say we could show that how, for example, LLM was summarizing these ones to a kind of, let's say, smaller chunk to provide the response, and it could increase the explainability easily. The other thing is the kind of GDPR issue. So I put a figure here that a lot of kind of big fines that happen regarding the kind of, let's say, GDPR violations. You could see different fines that we have. And one of the things that can happen when we are dealing with such case is that we could have the problem of data leakage. So I put kind of, say, a figure here that you could have places, names, email addresses, person names, organization names, and so on within the documents. And someone without proper access might be able to access those information through the LLM that you are designing or SLM that you are designing. So having a layer of data leakage detection not only is essential, but also it is based on the kind of, let's say, GDPR rules that we need to have to make sure that we are protecting the privacy of our customers. Another thing that we were trying to do was to see kind of, say, if we have a measurable bias in the kind of, say, LLMs or SLMs that we are using. We have a specific approach that is designed at University of Hull for explaining the input token of LLMs. So if you want to read more about it, just search LLM explainability using GSMI. And this method works in a way that it's for whatever input prompt that you have and whatever LLM that you have in a model agnostic way could tell you that, okay, what is the focus of the model for each words that you put as an input? And it could tell you that when you change the kind of, say, the narrative, for example, you ask what is the meaning of life, and we are expecting life and meaning to be the most important part of that question. But if you are asking what is the meaning of life from men perspective or from women perspective, and then you will see that for different language models, the kind of the focus of the model is significantly changing. And it shows a specific or can show us an evidence that these models have an internal bias. So if you are putting an information that talking about his or her or kind of, let's say, have any kind of, let's say, sensitive information that are subject to bias, you should have an understanding that, okay, there is a bias happening for this one. So these tools can help us to understand the behavior of large language models or small language models. And we could have a better kind of, let's say, artifact of for evaluating our developed system. So finalizing these two projects, kind of say that we had done as part of knowledge transfer, I would like to talk about another topic that is being kind of as a part of National Edge AI Hub. So it is what is National Edge AI Hub? So the UK had used or spent 100 million to boost AI research for proper transformative kind of innovations. And we are part of one of those hubs that called National Edge AI Hub. This specific hub is focusing on edge AI, led by Newcastle, and at the beginning it was kind of like co-led by 15 universities, and nowadays it is 20 university partner universities across the UK. It has 20 million grant from EPSRC, and it is kind of like one of the 9 hubs that got funded. And it has a lot of supporting by kind of the different organizations, more than 53 ones. So from the hardware side to Edge AI, IoT, the innovation agencies for healthcare, applied AI, and so on. And it has a specific focus to try to kind of say address different issues or challenges that we have for edge AI solutions. One of them is cyber disturbance in edge AI. Imagine that you have the cloud computing and then you have edge computing in a distributed way, and you know you could have known or unknown cyber attacks. And we wanted to see what is the real time learning quality that we have. So when we have model reconstruction attack, we could have data leakage attack, we could have adversarial data injection, and so on. And we could have also data quality measurements. For example, what is the missing data ratio? Do we have duplicated data? Do we have poison data or lazy data? All of these are the challenges that we have when we are trying to address edge computing. So we have done a couple of projects specifically as part of National Edge AI. One of them was called Hybrid VFL. So the idea of this hybrid VFL was to do safeguarding privacy for edge AI solutions in healthcare. So we all know that healthcare is one of the kind of highly regulated domains. So it is very hard to kind of say share data within the kind of say healthcare domain. So one of the easiest kind of say approach is to use federated scheme that you could have, for example, instead of asking them to share data with you, you could say, okay, I have this big model, I can distribute this model, and then the model can be trained and used locally. But one of the problems that we have for these models is that the kind of there are research that's shown they are showing that this federated learning approaches the data can be leaked in this kind of approaches as well. So how it works is that you have one server model, you distribute your models to the different clients, they can run and train it locally, and they just push back the kind of say weights and biases of that trained neural network to the server to aggregate and send them back the kind of updated models. So by doing this, they don't share any data, but they share models. And one of the kind of the issues that is happening for this specific part is that the research that shows that even if you don't share your data, some of your data could be reconstructed using those shared models. And we were trying to protect that one to be shared by using some kind of privacy um, uh, prevention metrics. And we were trying to show that it is, for example, using for skin cancer example. So if you want to read more about it, I put the paper at the bottom to read further about this topic. The other thing that we had is the kind of see the idea of using the pruning. So what is pruning and how it works? So in a pruning kind of say algorithm, whenever you have the kind of let's say computation restriction, you have a large model and you start to remove the redundancies. You try to prune and cut different parts of your neural network, for example. And by cutting unnecessary part or inactive parts, you make the kind of let's say model smaller without losing kind of say the performance and other metrics. And we were kind of seeing one of the projects that we had, we were showing that how we could use skewness within the internal layers of swing transformers or a multimodal swing transformers to make the model smaller without using kind of say without losing the kind of say the outcome performances, the accuracy that the model has. And it kind of uses explainability to guide pruning and kind of reduce the computational complexity of the approach that we have. So talking about these ones, let me talk about responsible AI techniques, specifically explainability and fairness that we have, and a bit of talk about AI safety part as well. So when we talk about anything about responsible AI and AI safety, we need to understand different tiers of the AI application. So based on EU AI Act, and UK AI Act is also similar to this one, we have 4 different levels. So the first level is prohibited AI. If you are working with the domain that any decision making can kind of, let's say, damage human life, you should be prohibited to use AI. For example, if you are using an AI to control a nuclear power plant, or to control a kind of to fully control an aircraft, or for example, anything that is related to the life of human, it is prohibited. The other one that we could have a high risk AI one. So for example, if you want to have AI for auditing, fraud detection, credit scoring, it is still considered as a high risk, and it requires a kind of, let's say, compliance report. So you need to show artifacts that you have evaluated and tested your solution to show that it is explainable, fair, and trustworthy, and so on. So you need to provide evidence for different kind of say responsibility aspects or trustworthiness aspects of it. And it has penalties more than up to 7% of the global turnover that a company has. So we have 2 other categories. We have the low risk one. For example, if you use AI for reporting, drafting data, or visualization. And we have another, the last category, that is no risk AI. So if you have basic automation for kind of say decisions, tools that it has no kind of say decision making impact. So that should be fine to use AI. So with regards to AI safety issue, I would like to show this specific video that is an old one from Tesla. So it is showing kind of say it is available on YouTube, and it is showing the Tesla Model Y kind of reacting weirdly when this horse-drawn carriage appears in front of it. And it shows the idea that if your model haven't seen something before, it can kind of say act weirdly, and we could call it out of distribution problem. So with regards to this specific problem, we were designing a solution, we call it SafeML. So I'm trying to showcase the idea of SafeML for autonomous driving system. So imagine that you have an autonomous driving system, and one of the duties that this, for example, system has is to detect the traffic sign. So you could have an embedded camera on your autonomous car, and you could say, okay, the traffic sign is 80 kilometers, and we load that kind of say image to the kind of say pre-processing unit, and we might have a machine learning or deep learning classifier to tell whether it is a what traffic sign it is. But different scenarios can happen. Sometimes you have a traffic sign that is clean without any noise, but maybe your camera is dirty, or maybe you have noisy situation, or maybe there's a rainy weather. For some kind of unknown cases, you might have an input like this one. So one thing that it does, the kind of SafeML solution it does, whatever decision that your traffic sign detector makes, it is going to another layer, we call it safety monitoring, SafeML safety monitoring. And what it does is that it checks the data from the certified database that you have for traffic signs. So your model says that, okay, I'm detecting 80 kilometers. It immediately uses statistical metrics to check it with the data set. And if there is a kind of say any distributional shift, it can tell you that something is going wrong and provide a specific actions. So if the confidence is very low, we could ask the driver to do manual driving if it is kind of say possible in a short amount of time. If it is kind of say low confidence, we could request for more data or communicate with nearby cars in the future, for example. And if we have high confidence, we could accept a decision and we could generate the required action, brake or speed up and send it to the control unit. We should consider that these decisions should be should be made on the car. So because imagine that your car is kind of controlling the health system, doing fully autopilot kind of system, and imagine that you have internet connection issue and there is a kind of connectivity issue. So you are not relying on cloud in this cloud systems in this specific application. Every decision should be made on the car itself, and any kind of issue should be also solved on the car. So we need to understand the idea of edge kind of computing and how we need to reduce the size of these models inside this car, and also reduce the trustworthiness layers, computations also for these limited computations that each car might have. And the other thing that I wanted to discuss is the explainability that we have for these solutions. So when we talk about explainability, I want to talk about the idea of, for example, how explainability can be done. So it could be with regards to the model type, it could be after training, we call it post hoc. It could be global, like feature importance. It could be local and showing, for example, some instances values. We have various kind of, methods for that. One of them called LIME here. So it could show that, okay, for a specific patient, what are the important features that are selecting? And one of the problems that happens for this one is adversarial attack on the explainability itself. Research in 2020 showed that one. And it showed that an unrelated column with adversarial attack could fool the LIME approach to show that it is an important kind of feature. While SHAP and SMILE were the method that we developed at all were robust or were resisting to show that feature as an important one. Although they were showing that one as important, but they were showing the other features, not ignoring them. And we were expanding that one for GSMILE, as I mentioned. It could now show, for example, an LLM input. It could work for any multimodal system and multimodal large model. And it could show the kind of input token or input prompt kind of importance for these cases. Last but not least is the fairness part, that we have different categories, race, color, ethnicity, that should be taken care of whenever we have these sensitive attributes. And we could have different stakeholders, for example, data scientists, business owners, regulator, consumer, and the different fairness advocacy group. So we need to understand, okay, what are the different level of kind of groups that we have. And to make it easier, fairness is about, if we have gender, for example, we have men and women. If your model has a specific accuracy, what is the accuracy for men and what is the accuracy for women? What is the accuracy for example, people with lighter skin color and people with darker skin color, and how imbalanced it is? So that's a measure of showing fairness, and we want to tackle that. And when it comes to the idea of responsible AI techniques on the edge, we have additional problems. So what are the additional problems? So first thing, if we talk about explainability, we cannot simply say we send the data to cloud for explainability, because that's the idea that for many cases that we have, for example, federated learning, split learning, and so on. The idea is that the data should not leave the customer kind of point. So we have the edge devices to do the calculation, not sending the data for the cloud. And if you want to run the explainability, it should be on the edge. The other thing is that, like the one that I was discussing about the autonomous car, for example, if we have a kind of latency, if you are sending the information to the cloud and imagine that something goes wrong, an obstacle in front of you in the road, you are going with 100 kilometer speed and you have full autonomy on the driving, and then something happens. So you cannot say that, okay, the internet connection was not working and the AI solution or the cloud-based solution couldn't kind of, let's say, detect or provide proper control action. So everything should be on the car, on the kind of, let's say, local device. So when we talk about kind of say safety, it is important to know that the latency that we have is an issue. So for many applications, we need to have the kind of, let's say, the AI and responsible side of it as well on the device, on the edge side. And we could kind of say have the accountability that should be immediate. So developing XAI for edge AI devices is hard, but why is hard? I'm going to talk about four different challenges, four different category of challenges. So we have system constraint, from performance to energy, from communication to bandwidth limit, from scale of device, and the kind of say device diversity, from physical and environmental constraint that we have. The second challenge that we have is the data and the model constraint. We can have the issue of data privacy and security risk. We could have continual adaptation and model drift over time. We could have multimodality and complexity in the data. And each of them have kind of, let's say, specific challenges and specific impacts on the edge devices. We could have challenges with regards to human and operations, and we could have human usability and interaction problem. We could have governance standards and safety problems limited for the edge AI devices. We could have network challenges. For example, we might have no internet connectivity in some rural areas. So these were the challenges. But if we talk about, for example, system constraint, the blue part, if we have the kind of, let's say, performance and energy constraint, maybe we could use model quantization, model pruning, knowledge distillation, and hardware acceleration. If we have communication and bandwidth limit, we might have to use edge inference. We might have to use data compression, even trigger transmissions, for example. If we have a scale and device, for example, diversity, we would have constraints, making constraint on our device, or making a model agnostic explainability. If we have physical and environmental constraint, we could regularize the hardware, we could have energy harvesting equipment, we could have thermal management, and many other things. So for each of them, we were trying to kind of say show examples and solutions here, but they are not limited to these ones. So again, for data, for example, and model, we could have continual adaptation and model drift. So how we deal with this one, we have online learning and continual learning. We have drift detection algorithm. We have active learning that can be used here. For human and operation challenges that we have, we could have visual dashboard, for example, for usability and interaction. Just like for the lawyer one that we were developing a dashboard to show all these level of hallucination, explainability to the user to increase the trust level as well. Interactive explainability and so on. So all these are kind of like the challenges and the solutions that we were thinking that we could have at the moment. So talking about the kind of, let's say, the performance and energy, there are four kind of, let's say, main parts that we could have. One is the quantization. So we could reduce the model precision if we use, for example, the float point 32 to integer with 8 kind of, let's say, bit of information. So we could have, we call it fixed point computing. So we could reduce the kind of, say, imagine that you are using a kind of, say, laptop to train your model, and then you need to convert it to a lower version to run it on Arduino, for example, with integer 8-bit kind of, say, processor. So for that one, you kind of need to do quantization. And when you do the fixed point computing problem, you will see that the kind of decisions that you make that are not that much smooth. The other problem that we have is that when we do pruning, we remove less important neurons and filter, but sometimes we kind of say destroy the kind of explainability or fairness of the model. When we do the distillation, we have, for example, a small model like a student, and we use teacher for that. We could have the kind of hardware acceleration. We could have kind of say edge TPUs, MPUs, DSPs, or CUDA, but they are also expensive to use on different kind of applications. So we should be aware of this kind of let's say cost that is associated with this. So with regards to the future direction, one potential future direction that we could think about, two potential direction that we could think about is one is resource-aware XAI techniques.
Hello,
So,
Karush, sorry to interrupt.
No worries.
Just you asked for a nudge when you had 5 minutes left.
Yep, I'm going to finish it soon then. Thank you. So with regards to kind of, I'm going to be a bit faster. So with regards to future direction, if you have an XAI solution that is designed for edge devices, that is resource aware, it knows that the computation is limited, it would be an advantage. If you have tiny, instead of tiny ML or tiny AI, we could have tiny XAI that are kind of say designed for not only have the performance but also have explanations. So one of the things that we were thinking is to use that kind of let's say pruning, but with the awareness of explainability of the model, and we make the model explainable enough to kind of say not only be pruned for edge devices, but be also kind of say applicable for explainability. So that's one of them that I would suggest to read the paper that we have in this part. The other direction that we have is that we have attempts to prune explanation critical pathways, so the model compress without losing interpretability. But the other thing is that to use causal explainability, combine the causality that we have from the data, the system, and integrate it with the explainability. For example, the Lime, Smile, Shapley, these methods. If you combine them together, the research shows that it increased the kind of the level of explainability. And we could kind of say that there are almost never combining the edge constraint, federated learning setting, or distributed setting, the pruning and XAR all together. So that's one of the open problems that we have at the moment. The other thing that we have with regards to fairness, imagine that the smart speaker that I was discussing at the beginning, each speaker only sees one specific patient, or for example, one person. So it is not kind of say aware of all other kind of say care homes, or kind of say all other kind of say devices. So with regards to fairness and bias detection, it cannot be detected in that level. So we need to have an oversight kind of say consideration to be aware of the kind of say bias and fairness issues inside these kind of say devices that we have. So to have final take-home message, we could say that fairness and explainability at edge remain emerging research area with significant scope for new methods, benchmark, and practical deployment frameworks. We have the idea of federated learning adds both complexity and opportunity, because model must operate across distributed, heterogeneous, and resource-constrained environments. We have real-world edge AI that cannot treat fairness, explainability, performance, and safety in isolation. These objectives must be considered together during the design, training, deployment, and monitoring. Practical deployment must address operational constraints, including limited connectivity, device constraint, data heterogeneity, decentralization, privacy, and change in the runtime conditions in an adaptive system. And responsible AI at edge requires fairness, safety, and explainability to become first-class optimization goal. At the moment, we are not seeing this kind of say direction, when we need more kind of focus on this, alongside the accuracy, efficiency, and robustness that has been kind of considered in many applications. So I would like to thank you. I'm showing the kind of, let's say, I'm acknowledging the founders and industry partners that we had for some of the cases that I showed in this presentation. And I would like to thank you for your time and listening to this presentation. And I would like to acknowledge the people behind this presentation, a lot of kind of PhD students, postdoc professors at University of Hull and responsible AI team that are behind all those amazing research that you saw in this direction.
Thank you, Kurush. Quite briefly, because I'm going to have to shoot off in a few minutes. Welcome to all our viewers from India. On a personal note, I keep hearing that small language models are the sort of the cutting edge of where we are in the AI world and running locally. So it's interesting to hear you sort of echo that. We had a question from Scott Forshaw. In the case of the Smart Speaker project, you mentioned semantic indexing and retrieval. What challenges did you face in security, speed, and selection of context-relevant data for RAG?
Okay, so one of the problems that we had is the kind of a security injection that we, for example, without proper kind of security levels, someone could do the prompt injection or jailbreak and to access some of these information, sensitive information. So we needed to have additional kind of layers for detecting data leakage and additional layer for kind of additional prompt injection mitigation layer to avoid such phenomena. But there's still there are ongoing research to make these algorithms for detection and mitigation to be improved. The other thing that we were doing with regards to the retrieval side of things and the semantic retrieval side of things is that one thing that we had was that at the beginning, if you dump every information that you have, for example, you have the information about what is the residence ID, what is the kind of the category, what is the description all together to the system to understand. If you leave it like that, we were getting a very low accuracy. But we were trying to kind of, let's say, identify in a kind of hierarchical way, retrieving the residence ID separately, then category separately, and then the kind of the transcription or the information for that user. By doing that, we were being able to increase the kind of, let's say, uh, accuracy of the model. And we were using the embedding space, and we were using methods like sustained distance to see the kind of, let's say, similarity of the response that we were getting with the ground truths that we had for the test cases. We had more than 300 test cases specifically designed for that smart speaker to make sure for each different categories, each different edge cases, we are kind of, let's say, having the proper kind of, say, investigation.
Great. So I hope that answers your question, Scott. Rajni, do you have any closing questions or remarks?
Very, very quick one. Yes, thanks, John, and thanks, Kurosh. Very, very informative presentation that. So, you started off with the AI assessment framework and whether I think a lot of these principles, taxonomies apply to both edge and cloud. Aside from the studies you're doing, is there any plan for, or is there already, let's say, a standard that exists that companies have to comply to, or these are the initial findings from industry and academia, and then the plan is to take it to a standards body? I mean, what's the future pathway to this piece of work overall?
So in overall, I could say yes. The answer is that a lot of these ones are kind of, say, mostly are in kind of, say, discussion groups that the different standards community they have. So they are kind of drafting, at least at the moment. So soon we will see they are coming in the standards. I myself, for example, I was part of a kind of, say, study that we were trying to regulate these ones for manufacturing in collaboration with Manufacturing Catapult and University of Warwick, for example, or some IEEE kind of, say, working groups for developing these as standards. And with regards, for example, for that safety cases that I showed for this first one, we know that AI Security Institute, they are at least at the moment publishing some white papers, and they are trying to kind of, say, put some policy documents later for kind of, say, making this one more clear and more standardized. I hope it answered your question.
No, it does. Yeah, thanks.
No worries.
Okay, let's call it there. Thank you once again, Kurush. Please look out for next month's event, which will be published soon. Thanks to my co-host Rajni, as usual, and thank you to all our viewers from all over the world. We'll see you next time.
Thank you. Bye.
Have a good time. Bye.